Hello once again, ladies and gentlemen. Root Beer here with question number 2 now on the 2004 Hypatia contest. So the grade 11 written contest as opposed to the multiple choice. That's the 2004 Fairmath. That's a different series of videos. Okay, so hopefully you've downloaded a copy of the contest for yourself. I've got my copy. Let's take a look at question 2. Alright, so two basketball players, Alan and Bobby, are standing on level ground near a lamppost, which is 8 meters tall. What? Is there a reason they're basketball players? Because it looks like we're just casting shadows here. Each of the two players cast a shadow on the ground. In the diagram, part A. In the diagram, Alan is standing 2 meters from the lamppost. If Alan is 2 meters tall, determine the value of x, the length of his shadow. And if we read B, this has nothing to do with basketball players. Is it just because they want to justify someone being 2 meters tall? Whatever. So we got a diagram here. Now, I don't know about you, but when I downloaded it, I don't know. This happened with the Yellow as well. It's very hard to read the numbers on their diagram. I remember this contest. It was legible what's going on. Now, fortunately, we have enough information in the question. 8 meters tall. So if we look at our diagram, this squiggle under the lamp, this word is lamp, has got to be 8. And then we've got 2 and 2 because he's standing 2 meters from the lamppost and he's 2 meters tall. And so it's left for the shadow to be x. So determine the length of his shadow. All right, well, let's just draw a picture in our notebook and see what we can see. It's likely going to be a similar triangle-style question. So these are light. And we've got 8. Now, the lamppost is standing straight up, as lampposts do. It's level ground. They told us that in the question. And we've got 2 meters here, 8 meters tall. So light's hitting him, and it casts a shadow. 2 meters tall here, and x. So what we've got, he's standing straight up, so we've got a right angle there, and we have the same angle here. So we might label things, say L, P for post, A for Alan, G for ground, and S for shadow. Okay, so I might make the observation that ASG is the same as angle LSP, and AGS is LPS, 90 degrees. So triangles ASG and triangle LSP are similar. Now the reason I want this is because I need to get some equation involving these known values and this x. So now I know that x, so since they're similar, this length, GS, is proportional to PS in the same way that AG is proportional to LP. So I might say something like, by similarity, so just similar triangle question, GS over PS is the same as AG over LP. Okay, well, I know GS is x, PS is 2 plus x. AG, well, that's just Alan's height from the ground up to Alan. And LP, the height of the lamppost, 8. Okay, so just a little cross multiplication. And we'll be all set here. So 8x is 4 plus 2x. I'll bring the 2 over to the other side. 6x is 4. X is 4 over 6, or 2/3 meter. So shadow is 2/3 of a meter long. And that was what we were asked for in meters. Determine the value of x, the length of the shadow. There we go. 2/3 of a meter. Okay, he's actually standing quite close to the lamp in terms of the light. It's quite a steep thing there. And we could sort of check, well, 8 to 2, that's a ratio of 4. And then we could say something like x over, so 2/3 over 2 plus 2/3, that's 2/3 to 8/3. Yeah, that's a ratio of 4 as well. Okay, not a whole lot to dwell on for that question. B part. Bobby is 1.5 meters tall and is standing on the opposite side of the lamppost from Ellen. How far from the lamppost should she stand? Oh, okay, Bobby. It's a girl spelling of Bobby. Okay. How far from the lamppost should she stand so that she casts a shadow of length 3 meters? Oh, okay. So now we're told the x value. We want to sort of figure out the 2 here. So let's draw a picture, and we'll label everything as is. Let y be the distance that she should stand from the lamppost. Okay, so we'll draw our picture. It's on the other side, so I'm actually going to draw the lamppost as though it were on the right. So she stands y distance, still the same lamppost height. And then we've got Bobby. She's standing this tall. No reason not to have the ground and L and P again. And hits her, casts a shadow for her. S, and we want the shadow to be 3. We know she's 1.5. So again, it's just going to be similar triangles. The same setup. We're just solving for a different part of what's going on here. Okay, so once again, we see similar triangles. I'm not going to write it all out again because it's the exact same reasoning, same angles, sort of, A in place of B, or sorry, B in place of A. I don't think it needs to be written out. If you do, when you try a contest like this, write it out more. It's important to try and figure out what you're comfortable with in terms of, does this count as an explanation? I'm doing it very casually. It's a video. I'm not actually earning marks here. No one's sitting marking me on this. So, I'm just going to say same argument. Same argument. And I think that's fine. It's quite obvious it's similar triangles. So, once again, we see similar triangles. I would name the triangles and make sure I get the names right. BGS, similar to LPS. You want to keep the order so that BG is the one that's proportional to LP, GS is the one that's proportional to PS, that sort of stuff. I think it's fine as long as you keep the proportional names there. It's quite clear that your triangles are similar in this way. Okay. So, LP over BG, not GB, BG. Keep the order correct. That's got to be the same ratio as PS over GS. So that's 8 over, I'm going to change 1.5 into 3 halves. So that's going to be the same as PS, which is y plus 3, over GS, which is 3. Okay. So cross multiply. 3 times 8 is 24. And then we're going to get 3 halves y plus 3. So 3 halves y plus 9 halves. Make everything into halves, so 48 halves. I'll bring the 9 halves over to the other side. So 48 minus 9 is 39. 39 halves is 3 halves times y. Multiply by halves, divide by 3, we get 13 is equal to y. So wow, y? 13 meters. Huh. I guess that makes sense. 13 there, that'd be 16 over 3. Well, 3 is just twice 1.5, and 16 is just twice 8. That makes sense. Okay. So, just sum it up with a little statement here. Bobby should stand 13 meters from the lamppost. Yeah, I'd say that was enough to get all the marks. Frankly, I think that's kind of an easy question number 2, considering it's the Hypatia. But, we might argue with an easy question. That just gives us more time for 3 and 4. And question 3 is exactly what we're going to look at in the next video. So thank you guys for watching. I'll see you next time.